Considering the need for reaching a sustainable and competitive bio-based European industry, high consideration should be given to the multi-use of the marine sector as main alternative of conventional natural resources. Biosea Project proposes greener ingredients from algae to give bioeconomy a boost. Biosea Project Consortium has been working for 36 months in close collaboration to reach successfully its main objective: development and validation of innovative, competitive and cost-effective upstream and downstream processes for microalgae and macroalgae cultivation, tailored cascading approach for ingredients obtention, and validation of final products containing greener algae ingredients. The project focused on the validation and scaling up of a complete production process of ingredients from 4 algae to be used in food, feed and cosmetic products through algae cultivation, extraction and purification, evaluation of active properties, formulation and evaluation of products, and LCA and social LCA assessment. The project work resulted in a range of replacement ingredients sourced from the microalgae and the macroalgae selected. In this sense, IGV optimized, cultivated and harvested microalgae Spirulina platensis and Nanochloropsis, produced in indoor closed photobioreactors and employing both glass photobioreactors and the mesh ultra-thin layer technology. This optimization process involved parameters control such as nutrients, light, carbon dioxide, temperature, thus reaching an increase of yield of ingredients of interest. Setaqua focused on the cultivation of the macroalgae Ulva ochnoi, first in laboratory-based photobioreactors, then further upscaled in open ponds and cultivated in cages, focusing on the seeding, harvesting and invasive species protection. Meanwhile, at Sinova optimized a patented advanced textile cultivation of Saccharina latissima in European seas, focusing on seeding technology, timing of seeding and harvesting, together with confronting with climatic influences. This new approach highlights the innovation throughout the replacement of the conventional 2D rope macroalgae cultivation in open seas, offering a great production yield through a larger cultivation surface. Vito, CNTA and Fayecon researchers have developed and upscaled zero-waste extraction protocols tailored for each of the 4 algae strains of the project, aiming for the extraction of useful products on a cascading basis, so that each refining stage produces new, useful products and nothing is discarded. Reagents and chemicals used by the project team have also been carefully selected for maximum sustainability. Their work has resulted in a range of replacement ingredients sourced from microalgae and macroalgae, including proteins, phycocyanin, fatty acids, carbohydrates, carotenoids, and lipids. The Biosea team, including Biopolis, CNTA, and ITEX, have already identified some added value in the obtained algal products applicable to the envisaged industry in the project, including ingredients that have an antimicrobial effect, provide protection against UV damage, offer fat reduction properties and antioxidant properties. The most promising compounds directly obtained from the extraction processes are employed in the development of functional food, feed and cosmetic products, with the aim of replacing conventional ingredients which may be imported or generate contamination with this high added value ingredient. For example, Soria Natural has replaced soy protein with algae protein for veggie burgers. CPC Feed suggested swapping fish plasma with algal proteins and macroalgal biomass in animal piglet feed. DBAC experimented the replacement of protein and polysaccharides in fish diets and developed antioxidants and other ingredients from algae, such as lipids or sugars, were used by Henkel in cosmetic products as marine carriers, algae caviar and personal care products. Life cycle assessment and social life cycle assessment is performed for the validation of the feasibility of this complete production process of ingredients of algae into industrial products. Considering the definition of the profile of each product and societal acceptance of this new sustainable ingredient source, scientists working on the EU-funded Biosea project are putting this idea into practice, seeking innovative ways of growing algae and microalgae in bioreactors and in Europe's open sea, to create more eco-friendly, cost-effective substitutes for a range of conventional product ingredients.